That's a decent amount. Okay, so, the beginning of this talk is going to sort of basically give you a little brief overview of what PD is and sort of general plugin development things, and then I'm going to sort of jump into these various tips and tricks that I find useful. I've been working on PD for quite a while now in Eclipse, and I have all these little things that I have learned along the way that help me in my daily job. So I'm very informal when I talk, so if you kind of see something that doesn't make sense to you, feel free to stop me and ask a question. Just raise your hand, and I'll stop myself and get to your question. So that's okay with everyone. I'll begin. So here's one of my favorite screenshots, that we've came up with over at the PD team. So basically, this is your screenshot of the Eclipse workbench, and then you see within workbench all the little different colored pieces all come from different various components within Eclipse. You see, you have the workbench, you have user assistance that provides the help, you have the perspectives, you have all these various little things that come together, and all these things are seamlessly integrated together, and they're all plugins, right? Everything is a plugin that you see on the Eclipse workbench. So what is PDE? What do I work on? It's the plugin development environment. So basically, anything that you use to develop plugins is something that is from PD. So we have wizards to create and export, import-export plugins. We got templates for new plugins. A lot of you, whoever actually contributed something to Eclipse, you probably use those fancy little new templates we have for like adding a new view or adding a little command. So that's all part of PD. We have internationalization tools. So anything that you do within Eclipse regarding plugins is something that is provided by the PD team. So, just like everything else in Eclipse, PD is implemented as a set of plugins built on top of the Java development tools. We're seamlessly integrated into Eclipse, and just like everything else in Eclipse, we don't get any special treatment from the JDT or the platform in terms of how we integrate. So, like I said, it's plugins all the way down. To basically build on top of Eclipse, you got to write a plugin. To extend Eclipse, you got to write a plugin. To write a rich client, you have to, rich client application, you have to write a plugin. To write an OSGI-based application, you have to write a plugin. So this talk is all about basically little tips and tricks that you could use basically on your own plugin writing adventures. So, the first one I have here is target management. How many of you are familiar with the concept of a target platform in Eclipse? So, okay, that's a decent amount. So basically, how I explain this is when you launch Eclipse and you start creating plugins, PD by default points to your running instance as the target platform. So when you create a new plugin project, you're basically developing against what you're currently running against. What's common for people to do is they'll download the latest Eclipse. They'll get like 3.4, maybe Ganymede, tomorrow when it officially comes out, and say they're developing a product that maybe runs on Eclipse 3.3. So you could use the latest Eclipse, and you could point to another target platform maybe being your product based on 3.3 and have everything magically work, able to self-host and all that good stuff. So the target platform feature in Eclipse allows you to do that. So yeah, it's pretty simple and straightforward. Most people don't realize that you could actually develop against older versions of Eclipse using your target platform. So there's another good one in Eclipse called the plugins view. So if we go to the plugins view, let me show an example here. Let's see here. So we have the plugins view in Eclipse. A common use case for people is a lot of people that do Java development in Eclipse probably use the shortcut Control-Shift-T. Is that familiar for people? I guess it's Apple Shift-T. You pop up and you got like a bunch of classes you could browse to. So in the plugins view, besides just listing the plugins that you have available for you to work with, there's a neat little thing where you could basically let's find a class that I'm familiar. Let's add all the help ones. So you could right-click these, and there's an option called Add to Java Search. So what that does is basically PD adds these plugins to the Java search. So now when you search for like I help something, I help shows up in your search now, which did not show up before. So it's just a neat little way to basically have these classes available for your search. So what's common for what some people do, which I don't recommend depending on performance, is they'll basically select everything in that view and add it to Java search. So it's just a nice little way to jump to things based on what you have in your target platform. We don't, people have complained to us that we should sort of do this by default, but in the interest of performance, we don't do this. Yes, do you have a question there?
Yeah, I've noticed that for some tool frameworks, you need to actually unzip the source jars to be able to see the things. Is this if I were doing this, would I not need to do that?
So there needs to be source associated with these somehow, and there's a couple ways of doing that in PD. There's that source extension point, or it could actually be bundled with the jar, or there's a new way using a special Eclipse source bundle header now. But the source has to be, PD has to be aware somehow of how to get to the source. So
yeah, this was a case where the source is there, but it's all jarred up, and I actually needed to expand them for any of my searches into that plugin sources to work.
that's interesting. So
I was wondering if this was a way around that.
no, it should work. So I'd have to see. After the talk, we could look at it to see if that solves your problem. So okay, so that's the plugins view. Some people find it useful, but like I said, adding things to Java search is quite useful if you're quickly using Apple Shift T or Control Shift T to jump to various classes. Let's see what else do we have next on the plugin tip list. The error log. So your classic error log view. In 3.3, it was very plain. But in 3.4, which will be out tomorrow, we've added quite a few cool things. So let me demonstrate for you, because the best way to do it is to actually show you. So now, let's see, let me make it a little bigger. So we added some filtering, so you could actually search, for log entries if you wanted to, right? But other things we have done is you could group now, so you could group by session. So a common thing for people to do when they develop plugins is to self-host a lot, right? You'll make a change in your plugin, you launch to test, and you keep going through that iterative process. So you could group by session, and you could see basically which the various sessions where they are, what happens. So that's kind of useful in that regard. You could also group your entries by plugin. So you got to see where they come to. So if you're only interested in a specific set of plugins, you could easily browse that. Another cool thing that we did is if you use Eclipse, you're familiar with probably the concept of launch configurations and stuff like that. So you typically self-host by creating a launch configuration and launching it. So the log view is now aware of the various launch configurations you have, and also what you have launched and the logs associated with it. So for example, I have a launch configuration, just a typical workbench, which pretty much just launches all the plugins enabled that you have in your workspace and your target. And the log view here is aware of that, and you could jump to that log immediately associated with that with that launch configuration, so you can see a bunch of stuff. So this is basically, you can see the location here where that bad boy actually is. So this is quite useful if you're dealing with a lot of different launch configurations and you need to be able to quickly get to them. You could also jump back to the workspace, back to the home place too, so if you need to. So just a little, the log view got a little love during the 3.4 release, so it's just a good thing to know about some little things that could help you through your journey. Now moving on to, sure.
So what you said in there is, rather than having to look at the error log of the Eclipse that I launched from there,
Yes.
Eclipse from where I launched can actually give me the error logs.
Yep.
From the other.
Yep. Yeah, so by default, you see that it launches, here's a launch location, right? And if I actually jump in there, see if this works. Oh, it works.
Can you repeat the question?
Oh, so basically, I believe you, whatever your name is, you're asking, basically this feature now allows you to, instead of browsing to the log manually, like I'm doing here, with the runtime configuration, you basically have to jump to the workspace location and dig and find the logs. Instead of doing that, you are now able to just do this simply via the log view. So you can just go to that launch configuration and it'll jump to the log that's located there. So that's basically what the brunt of his question was doing. So yep, that does it for all your various launch configurations. All right, let's see what else we got here. Execution environments. How many people are familiar with execution environments at all? Probably not many. It's an OSGI-centric thing, but basically, when you build plugins, right, you're usually building them to target something, some type of environment. Well, execution environments are basically a way to say that, your plugin is only meant to run on maybe Java 1.4 or maybe Java 5.0. It's using fancy generics, so its minimum is that. And this is what's cool about this is that the OSGI runtime, or within Eclipse, will actually enforce this. So, for example, say your product needs to run on 1.4. So you're building a bunch of 1.4 plugins, but you also want to use some 5.0 stuff. So you build some 5.0 related things. So in case maybe your customer actually runs on 5.0, they'll be able to use these things. So what the runtime will do is, when it launches, it knows all its plugins. It knows all the execution environments associated with those plugins. If you're using 1.4, it's not going to load your plugins that specify an execution environment of as 5.0. So it's quite neat in that order. Also, when you're actually going to build your plugins, it actually sets up the proper compiler settings and stuff like that to make sure it gets built properly. If you're using 1.4, here are the magical settings you need to do for 1.4, and same with 5.0. So it's quite an interesting thing. It wasn't used that much in the past because there wasn't really good tooling for it in PD. But in 3.4 now, you'll notice that when you go create a new plugin project, you will see that. Let's cheat. Plugin, a new plugin project. You'll notice that pretty much you're given an option immediately now to specify an execution environment. So we're trying to get people to adopt this best practice in terms of specifying these. And you'll notice if you have old plugin projects that you import into 3.4, PDE will actually flag them with a warning, say that, oh, you should set something. This is a good thing to do. So keep that in mind when you're developing plugins. Sure. Sure.
So we've got a situation where the plugins we're developing need to be built in 1.5. The target system that we're running in needs to be 1.2. And of course that.
So you need.
So in other words, I'm building plugins to help develop that, right? Develop
Yeah, sure. But so they could run. So they could.
1.5 for the plugin to run. So Eclipse has to be running under 1.5. But the target code
could be 1.4.
Has to be 1.4.
Okay.
Because of some stupid order.
Okay, but can you? So is it okay for you to run on 1.5 too? I mean, it should be all gravy, right?
You can run on 1.5, but you've got to develop. There's one build step that needs to be on
Okay.
1.4 compiler, so you really need to have your development environment set up to 1.2. But once you've built your class files, then it can all execute. It's only this one. It's Oracle loaded Java procedures.
So if you need to.
Students aren't going into it, but the thrust of the question is, I need to run my plugin on 1.5.
Yep.
But I want to set it so that the target configuration is 1.2 when I'm running my plugin doing Java development.
So if you set your BRI, as we call it, the execution environment, you could set it 1.4. That implies, so it's going to set up your compiler settings to be all 1.4 gravy. The 1.4 gravy train.
So I'm developing my plugin, or as
When you're building, when you're going to build. So, what's up?
I can't build them on 1.4 for using generics.
So then what you would do is you would specify, so you could specify both, right? So if you specify, so we actually do that. So you could specify, we do this with the foundation type, you're familiar with foundation. So basically, certain things we need to compile against 1.4, but we could run on foundation 1.1. So you specify 1.4 and foundation. You could specify multiple BRIs here. So in your case, you would have an odd case where you specify 1.5 first, and then another 1.4 BRI. So basically, when you go to build and compile, it'll use 1.5, but you're saying you could also run on 1.4, which is quite weird. I don't know how you exactly do that, but we could talk about that offline. So, but basically, when you go to build, it uses the first entry in this list to set up the proper settings. Sure, we'll talk afterwards. So I mean, it's a little too much for the audience maybe. Okay, so now we have execution environments done. Let's look at something else. So OSGI launch configuration. How many in the room are familiar with the OSGI? Is that like a hot term for people? Yeah, so that's good. So PDE by default, PDE for a long time has supported plugins. Eclipse has had the concept of plugin for a long time. In the 3.0 timeframe, we actually chose to adopt OSGI as sort of the plugin modularity layer. PDE provides good tooling, just like you use the Eclipse application launch configuration. We have an OSGI launch configuration where you could specifically tinker with various OSGI environments. By default, of course, we work with the OSGI framework that ships with Eclipse, which is Equinox, but you're able to plug in your own if you wish, and there's some more advanced settings for people to toy with. How many of you remember Quake back in the day? Lots of Quake people in here? Yeah, Disney Smile. Remember that Quake console you had? You set up God mode. It was like IDD, QD, or whatever. So Eclipse has a similar concept. We have an OSGI console, so it kind of gives you that same power. There may not be like a God mode, but you still have. You can shoot things, yeah. So if you launch Eclipse with, let's find a little example here. Let's find my little hello let's see here. Let's put a dash console here. So if you launch with dash console, boop, you go to the console view, you got this little OSGI prompt, you know? So if you type help, you'll get a bunch of commands, but there's tons of commands around status, SS, like short status. You'll basically see the status of sort of all the bundles, available, to you within the runtime. You could do things like, let's see, orgeclipse.hi hasn't started, so you could start orgeclipse.hi, it starts, you could stop it, all these cool little things you could do within the console. You could diagnose bundles. So if your bundle is having a problem, you could diagnose it with, diag, and it's just a cute little thing to use sometimes to basically help debug certain scenarios. You could also pass basically, here's another sneaky, not really a secure way of doing things, but if you launched a console and you put, I believe, let's see, what's a mat equal? 4, 5, 6, 7. Oh, it's already running, so I can't do that. Let's do that again. So you could actually put a port number after that, and it'll launch the workbench, and you listen here, and you'll get a little console. Oh, I'm such a Mac noob still. What was it, 4, 5, 6, 7? Maybe not. Well, yeah, so here we go. I'm now working in, a Telnet. It's sort of a cheap way to do remote sort of administration or diagnosis in case maybe your environment is on some server and you just launch it to debug with. So it's just a different way to work with things. So what's cool about this console also is you could also provide custom commands, right? So if I linked an article up there, which you can go to, and it'll show you basically how to sort of contribute your own command to the console. When I was chilling outside this room, I wrote like a quick little example that contributed a little command. So I'm sure some of you are familiar with sort of like the uname type thing. Uname is a very common Unix type thing. So I just created this little command. So if I go back to my console, my plugin will start, you type uname, oh, I'm running on a Mac. So you could also provide custom commands here, for your own application, in case you need to do some debugging of some type or have some hooks into your application that you may not, have available to you. So it's just a nice little way to do that. So there's a good article I linked that I wrote a while ago that shows you how to do that with some nice examples. So there's the sure.
Do you happen to know anybody who's built test drivers?
So testing OSGI console commands?
OSGI bundles via OSGI console.
So yeah, that's possible. Like so he's basically asking, has someone created some type of test driver to, basically to test OSGI bundles? And I mean, you're probably asking for more than what is provided by sort of PD and the test framework, right? Because, we could launch, JUnit plugin tests, and you could test your series of plugins. You could also run this headless if you want to. Even the OSGI TCK comes up with a way to sort of remotely do this, where they'll deploy bundles and they'll run them and test them. So I don't think there's anything out there that, you could probably easily grab besides what ships with Eclipse. So, but we could chat offline about this issue if you're interested in it. All right, where was I? Oop, no more Quake. So there's the display. So this is less a plugin development tip, more of a normal Java development tip, because it's also usable in the Java context. So how many people are familiar with the display view at all? Not many? Okay, so this is actually something that needs to be shown live. So I have, here we go, I have my little bundle activator here. I have a breakpoint. So people are probably familiar with the concept of breakpoints. Breakpoints are good. Allows you to sort of basically go somewhere in your code and stop. So let me launch this bad boy. And so, it's in the debug mode asking me to, basically go to a breakpoint. Oh, I have another breakpoint here. So I got one here. So let's see here. Let's do another way. Let's continue on. Okay, this is the one I want to go to. So we have this breakpoint here, and we see that it's creating various things. So if you go actually to the display view, if you open up that guy here, you actually have access to sort of should have code completion. Yeah. So basically what you're doing is based on where you've stopped in your breakpoint, you're able to do certain things, right? So you could call, this method, or actually, how about this? Let's do this. System.out.println, line, hello. So you could basically execute a line of code in this context and, get a value. So basically it allows you to sort of stop and maybe toy with certain things that you have. It's quite nice. So this is sort of I use this probably like on a daily basis to like debug various aspects of code. Stop at a breakpoint and just chill for a while and see, maybe call this method, see what happens. So it's quite nice. And you get code completion in this view. This is one of sort of the hidden gems in Eclipse that most people just don't know about because it's probably not really widely publicized. So the other tip that kind of goes with this one, see, oh, sure, man in the back.
In the display, the thing that bugs me the most is that you actually have to select the thing to evaluate. It doesn't kind of do like by a line and by words. It's kind of clunky to do it.
Yeah. Yeah, so his question was, it's kind of clunky the way I'm executing this is that I have to actually select it and then basically hit execute for it to do something. So if you have a sort of a better way to do this, Eclipse is an open source community and we love patches. So if you have like sort of a better way to do it, feel free to contribute it back. I would be glad to see it because it is kind of annoying that you have to do that. But so back to this one. So conditional breakpoints. Do people know about conditional breakpoints? They're like my favorite thing in the world. Yeah, this guy knows about, Robert knows about conditional breakpoints. So now that we kind of understand this breakpoint concept, right? Imagine if we actually, write a little Java code to actually basically say that, I want to stop here based on certain conditions. Maybe you're entering a method with as a parameter called string ID, right? You enter an ID and say, that method is called by like a million people, right? It would be nice to maybe set up a little breakpoint that says, if ID equals maybe whatever I want it to, and have it just stop there instead of hitting you're just going to keep iterating until you get through. So we actually have a concept of we actually can do this in Eclipse. Yes, this guy. What's
the other thing is like conditional breakpoints based on some other breakpoint having been hit before.
Okay.
It would be really useful.
So I'll go back to the whole question of we're welcome to contribute anything you want. But so the good example I have on this one. So I set one up before for my presentation here. So since I'm pretty snazzy and sort of know the internals of the Equinox framework and stuff like that, there is one particular method here in it's called bundle loader, load class. So basically every class that is loaded by OSGI, or Equinox in this case, is going to go through this method. And so if you're trying to debug like, for example, you have some class and you get some weird class loading issue, right? If you imagine iterating through like the bazillion classes that happen when you load an Eclipse Workbench, it's going to take you an eternity, right? You'll age really quickly. So what I've done here is I've set a breakpoint, just like you normally set a breakpoint. You want to target it there. Then there's this fancy breakpoint properties here, right? Oh, enable condition, right? This sounds good, right? So I'm going to do that. And then I look at this method. So I got name is obviously here. So I want, name, equals, com.that Google dot, my class, right? So you would do that and then hit OK. And then you notice you get that little question mark, which implies a conditional breakpoint. So now when you go to launch, it's actually going to test that breakpoint for that condition. So it will actually stop and stop when it satisfies that condition. It's quite nice. I mean, I use this quite frequently, so I highly recommend it. If you ever had that moment where you're sitting debugging code and you're like, crap, I got to iterate through however many times I need you to get to what I'm really interested in. So it's quite useful. So this little this is one I like. If I have like top 10 breakpoints in Eclipse, this one is like number 2 or something like that, because if you're ever fighting, I guess for me more so since I'm do more of the low-level internal type stuff, but if you're ever fighting like class loading issues, you start there and then you just see what's going on. So it's just a little tip for you guys if you ever go to that aspect. All right, now that we're done with conditional breakpoints, what else do we got? Plugin dependencies view. So Wow. So I remember looking at the eBay presentation that went on, and there was like, I don't know how many, projects in their workspace. So you have the sort of same problem when you're developing plugins, right? Because you could have maybe like, maybe you have a really big product and you got like 100 plugins in your workspace. Sort of visualizing those dependencies is quite difficult. So in PDE, we actually have a plugin dependencies view. So let me show you this live in action here. So if I go to plugin dependencies, I have this nice little view. Let's turn this off. So let's focus on let's focus on my PD plugin, PD core. Right? Actually, no, let's do PD UI. Let's do that one. So you look at PD UI, and we have this concept of show, callees and callers. So right now you could directly see in this view what PD UI is depending on. So if you look at if you actually look at the manifest.mf inside a plugin, you could see, you list all your dependencies. This is sort of just a visualization of that. So you could just go through and drill down and see, oh, these are all the guys that are depending. These are all the plugins that PD UI is depending on. You could also flip this around, and you can actually see who is depending on, who needs PD UI. So you flip around and you see, these are the guys that are actually depending on, use PD UI in some way. So you sort of get the reverse perspective here. What's also cool is, some people like pictures, right? Pictures are like 1,000 words for people. I guess that's the old saying. So we have another way to visualize plugins. So if we have this project in the PD incubator called, I guess, the graph plugin dependencies view, so which gives you sort of visualization of things. So if we launch this guy, graph plugin dependencies, you guys see that okay? So we could focus on, let's focus on PD core here, and you get this nice little picture here that kind of shows you, what's going on. You could see the various dependencies all highlighted. What's also cool about this, you could also see, so for example, you're looking at all these crazy dependencies and you're like, all right, so these are my direct kind of dependencies, but you're also dragging in update core. You're like, why do I need update core? So you could do a dependency path and you click update core, and then you can see, it's this guy that's dragging in that beast for me. So, it'd be nice to get rid of him, but you can't. He just stays with you. And you could also do things like take a screenshot and all that good stuff. So here's a little preview. So it's quite nice, if you're trying to just sort of visualize maybe even your architecture of your application. It's a good way to sort of do this. And so this code right now just is in the incubator. We haven't been able to bring it in the SDK yet, but it's one of my dreams to actually do this because people find this visualization very useful. Yes, do you have a question?
Are you saying that I have to also use or enable people to use it for the Java class path?
So right now, this strictly works on the PDE class path container. So if someone wanted to write some visualization that worked on something else, they could. I mean, right now, this actually is not too much code, surprisingly. It uses a lightweight drawing framework called Zest. It's actually used to be part of the Mylan project, but now it's part of the graphical editor framework project, and it's great stuff. It allows you to create these basically, quick and easy graphical editors with not focusing too much on actually like the graph and UI code. You don't have to worry about like layouts and all these crazy things. You could just focus on like giving it a model. So, here's my model. Here's what I want to do with it. Here's a layout I want, and it'll do all the magic for you. So it's all good. Yep. Man in the back.
How tightly coupled is this incubator project to the plugins, to depending on the plugins?
So this specific code that you're looking at right now is part of the PD incubator, and it is quite tightly coupled to PDE. But the actual visualization you're seeing here, the stuff that enables you to do this, is not. It's off to the side, part of GEF. It's really small.
But how much? How much additional framework are you putting around it besides your dependency?
It's like I basically in PDE we have this concept of a state, right? Here's our state. The state has all the plugins, how they're related. Here's the state. It's sort of like JFace. If you use JFace, here's my model, here's my input, right? Similar concept. It handles all the graphing and all that stuff for you. It's very cool. It's really like Zest is one of my favorite projects out there in Eclipse because like if you ever done visualization is hard. It's a hard problem. You got to worry about lines intersecting and all these crazy layout type things, zooming, all this stuff. So Zest handles all that for you. So we could chat about it afterwards. I could point you to it. It's good stuff. All right, what next do we have in the plugin developers toolkit? Organized manifest wizard. So here's a little obscure thing that not many people know about. We have this tucked away. Actually, let me go back to the slide. So we have this guy tucked away in the PDE tools menu. But basically, we have this little cute little wizard that will basically allow you to sort of, we call it like scrub manifest. We got that little scrubber icon up there in the top right for the wizard. But basically, it will go through and do certain things in your plugin, right? For example, one thing we do in PDE is, or actually in Eclipse in general, we have this concept of exporting all of our packages, right? Basically your plugin, we want all our packages to be seen because we found that our adopters, no matter how much we want to try to hide stuff, they always want to use some crazy internal things. So we have to export everything. This wizard provides you sort of a way to do it automatically because it's sometimes common. You're creating a new you have an old plugin, you add a new package, and you forgot to add it to the manifest to export it. It does other things. You could actually scan and remove unused dependencies. One thing that sometimes happens is you're working on a plugin and you decide to add a ton of dependencies to it, right? This could actually scan and try to remove unused dependencies, amongst other things. Another common thing is NLS keys. Sometimes you're working on translation and externalizing strings. You refactor things around and you leave some strings externalized that aren't you really using anymore. This thing will come and catch that issue. So it's really easy to do. So if we go back to the Project Explorer, let's go here. You just right-click a plugin. Let's go to this one. This one's a little bit better. You click that. You do Organize Manifest. It's really a bad location, but actually let me open this guy. The other way to get to it is if you go to the overview page, it should appear in 3.4. Yep, it's here. So you could do Organize Manifest, you click it here, and then you could just show basic little things you could do. So, mark things internal if they have internal in a namespace type thing, all this good stuff. So it's there for you to use. It's often used by the Eclipse team, before we usually commit something. We usually run it through the Organized Manifest wizard right before a release just to make sure everything's in tip-top shape. All right, what's next? Product editor. If you're building products in Eclipse, if you're building RCP-based applications, PDE provides really good tooling for you to develop these things. It provides stuff. Here, you know what? I'm a big fan of actually just trying to do stuff. So let's see if I could do this live. Live demos are fun. So I'll create a quick little plugin project. Let's call it rcp.mail. We have a fantastic example that ships with Eclipse. So if you want to create a rich client application, hit yes. RCP mail template. Hit finish. Magical. So you do that, and what we could do is, so let's see here. So if we launch this guy, got a splash screen. Oh, we have a little product. So we have our own little custom product application. This is kind of a base template that we ship with. So one thing basically that you need to start focusing on when you develop products is you basically have to specify common questions are like should I bundle a JRE with this product? How do I brand this thing? All these little things that you need to do. So we have a concept of a product configuration in PDE that helps you control this. So I could create let's do it, mail.product based on the existing product I've defined. I click that. And bam, I have this file that basically, allows me to sort of specify all the plugins my product depends on in this mail application. Here's what I need. I could specify custom config.inize, which is kind of an advanced concept, but it's useful for some people. When you go to launching, you could also specify, maybe my product needs, J2SE 1.5, right? Or it needs, Java 1.4. So you could actually specify, basically, a JRE here. And when you go to build this product, it'll actually include the JRE, with your product. So it's quite useful. You could specify, the launcher name. You could maybe, if you're writing Android, maybe you call it Android.exe. So it's just a way of customizing the bits and pieces of your product. You could do program arguments, VM arguments, all that good stuff. You could customize the splash screen. So for example, if we want to use this, for example, we want a different splash screen, we could do this. Actually, let's try this one. So you save that. When you go to launch, I think we should get a new splash screen. Oh, I broke something. I was probably toying with things, so I probably broke something. Specify none. That's the bad thing about live demos. things break sometimes. All right, let's try it again. If not, I'll just move on. Yeah. So you get this customized little splash screen, right? So it just saves you a little time when you're developing your product. Oop. And there's also things with branding. So a common thing is branding a product with various images and welcome screens and stuff like that. So this is just like a one central area where you could all do this. So it's quite nice because what's also good about this is if you're familiar with building plugins or building products in Eclipse, building is an art form I like to refer to in Eclipse. It's a difficult task. You could actually drive your build using this file. So when you actually go to build, you point PD build to this file, and it'll magically build what you need to based off this file. So it's quite nice in that regard. But oh, man in the back.
Any support to a packaging product as an RCP implication over GNLP, or you don't need it, I can contribute it myself?
So we don't, in the product file, we don't provide that like an out-of-box thing you could do. But when you actually go, I think we have this in the actual product export wizard. Let me, let's just call this something blah. Oh, come on, stop being so I'm pretty sure, come on, let's just put this guy somewhere, /opt. So if you, no, we don't have it for that. No, so you could do it when you export features and plugins, you could do that, but we don't have support for that like sort of in a UI way, but via like a sort of headless and command line, you could do it as part of PD build. It's something PD build provides, but we don't have it exposed in the UI for products. We could talk about it later. But you could also contribute it back if you wanted to, if you want something in the UI there. More than welcome to. Okay. Doing okay here. Externalized strings. So eventually, you could try to develop everything in English, but you'll be surprised there's someone else who wants to use it in some different locale. So we have an easy wizard in PD called the externalized string wizards, which enables you to externalize things really easily. So oh, here I have my little mail product. So I could quickly go PD tools. I could do externalize strings. And I got this awesome little wizard that will basically show me all the little, basically externalize everything it finds for me manually. So you don't have to do this by hand. It's quite nice. It's kind of like the Java tools provide this type of thing. So it's quite nice. Sets it up all for you. You don't have to worry about it. Don't have to think about this. Just make sure to do it every so often when you're developing. So what other cool stuff do we got here? So when they develop plugins, you're probably familiar with versions, right? The way in Eclipse you have a major, minor, and a micro version. So for 3.4 we have 3.4.0. Well, there's another dot you could put. You could put 3.4.0 dot qualifier. That dot qualifier is something that by default, when you go to build or export your plugin, it's set at for today's date or whatever time, like timestamp. It just gets a timestamp. But you could actually customize this to be whatever value you need, depending on whatever requirements you have for your product. So it's common for people to use this. And we also in the export wizard, you could also set it to be whatever you want to, because we have common cases where, for example, you have a lockdown product and you want to be kind of, you don't want to like reinstall your plugin. You kind of could be naughty and like set it to be whatever the date was in that product, export and like drop it in and restart, and it's just a little way to sort of do things. But I highly recommend always specifying the dot qualifier. It's harmless. We also have the plugin registry view, which is really cool. So remember that console I showed you? Well, you could kind of view this as almost a visual representation into the console. So this basically shows you everything that's currently running in your current application here. So we see that a couple plugins are all launched and good to go. You could do you could show extension points only, so you could quickly browse various extensions and see cool things like that. But the cool little thing that we added recently in 3.4 was this little show advanced operations thing. You click that, oh, and now we could be really naughty and we could start like starting things, and I don't want to stop that. That's bad. So you can start and stop things all from this visual thing, and you're also able to diagnose plugins. If there's a problem with it, you don't know why. You get a nice little informative pop-up of what's going on. So it's that. Oh yeah, I didn't show the cool thing. You could also use this to like, for example, you're looking for like maybe something like the log view. You could type like log view maybe. Yeah, and you could see like various, it just quickly shows you all the extensions and all the good stuff that's contributed by various people. It's quite nice. All right, in the interest of time. So another common thing for people to do is, you're developing plugins and all of a sudden you have like some third-party dependencies. Maybe you have like Hibernate or you have something else out there that you need to drag in, some like Commons, whatever. So we have a nice little wizard called Plugin Project from Existing Jars. So what you do is you launch this wizard, you point to the jars you want, and when you hit finish, it'll generate you a new plugin project with all those jars embedded into it and all the classes there available for reuse. So this is a nice way to sort of bundle any external dependencies that you have that may not be plugins already. So this allows you to convert external dependencies into a nice plugin. Yes, Mr. Rob.
Can you talk about having a feature like that running from running without a UI only? If I'm not mistaken, I've been trying to do something similar.
Yep.
But I needed to run automatic as part of another task. So part of another operation.
Okay.
Wondering,
Is it because you want to generate your own?
if I recall correctly, when I was looking at what you were saying,
Yeah, well, yeah, that code is in itself is quite tightly coupled to the UI. But we could talk about it offline because there's other tools to sort of do that. There's something called BND that does something similar, but we could talk about that later. I think I'm breezing through here. Okay, let's talk about some of the newer stuff in 3.4. So here's something called I call Plugin Spy. So let's show you the normal example I like to show. So a common thing for me in Eclipse was, when I started developing is, I see some cool code out there. I see like the error. The common case for me is, I was developing an RCP application. I see the error log view, and I was like, I want that in my application, right? How do I get that, or how do they do this, with code? So the plugin spy and sort of the way like Firebug works, if you ever use Firefox or did some like web app development, kind of does a similar thing to Eclipse. You're able to introspect the workbench. So basically, I have the log view selected. And if I hit Alt-Shift-F1, you get a little pop-up called the Plugin Spy. And what it shows you is that the view that you're looking at, is the error log view. The class that implements it is log view. So you could, immediately jump to that class if you wanted to. It comes from this plugin. Here's the identifier that the views use. Here's any like help context IDs associated with it. So within like a click, you're able, to jump to the source for what you're looking at, right? You can even get fancier and like, for example, say you wanted to contribute to the menu of, like the plugin dependencies here. You hit it here, and, oh, I did the wrong shortcut. You hit it here, and, now you see that, the active view is a package explorer part, and, here's, the active selection here is a class path container. So you're able to sort of introspect what's going on in the workbench and able to quickly see what you may be interested in. So it's just a common, this was really born out of my frustration of trying to find stuff inside of Eclipse or finding a magical ID that I needed. So, it's been quite popular with people, and I hope to extend it in the future with some new abilities. Another cool thing, a lot of you are probably familiar with the Control-Shift-T, basically in searching for Java classes. So I decided to come up with something similar in PDE. So basically, it's called Open Plugin Artifact. You hit Command-Shift-A, and now you could search for things like org Eclipse, and let's say JDT, oop, I misspelled it, and you could quickly jump to various plugins, extension points, extensions, and even packages, exported packages. So you're able to jump within sort of one quick shortcut to various places. You jump to an extension, you eventually jump to an extension. You'll see, oh, there it is. So it's quite nice. It's, you kind of get used to these shortcuts doing Java development. You want to do the same thing with plugins. All right, moving on. API tooling. This is my last one, I believe. Nope, we could skip target editor. But so API tooling was something new that we came up to in Eclipse. Basically, the biggest problem you have when you start developing plugins, you start modularizing your applications, sort of keeping consistent with versions. So for example, in Eclipse we have this thing. So if we have API in 3.3, right, and we move to 3.4, we have to guarantee that API works. So what you do is when you declare API, you have to be careful. Like, maybe changing a method signature is going to break binary compatibility, right? So you have to be very careful when you craft your APIs. And this is always something painful that we dealt, basically every release, at the end of the release, we had the API police, right? And they would go and scan code and try to figure out who broke what, who maybe added a method or removed a method that would break compatibility. So we actually created tooling in the 3.4 release to do this type of stuff. So I actually have a little example that shows some of the power that you could do with API tooling. So this is not the best example, but you'll get an idea of what you could do. So I have like a sample little view I created, and I annotated it with something called no extend. It's just a little Java doc thing that API tooling uses. You declare no extend, and you could also do this on method level too. So you could do no override. So if we look at another plugin, I have another plugin there that actually extends this guy. I have sample view 2, right? This guy extends sample view. And if you notice, in the problems view, we have some warnings for us. Sample view illegally extend, or sample view 2 illegally extends sample view. And we also have sample view 2 illegally overrides this stuff. And this is the type of stuff that API tools allows you to do. And it's actually quite highly configurable. So if you look at this is where you could set your what considers an API warning or binary compatibility issue. You could set all these various things to basically tweak how you want to do things. It also handles version management. If you could declare API and you forget to add a since tag in Eclipse, we like to you declare API, we'll add since 3.4 or since 3.3. It will catch these issues for you and like throw up errors and markers. So this is really cool stuff if you are really worried about version management. So I guess in the interest of time, I will open things up for questions. Yep. So for Q&A, does anyone have questions? I mean, I'm available also offline pretty much until the end of this for questions. But any questions before I wrap things up? All that? We'll close it up. So thanks, everyone.
Did anybody follow the development of real-time shared editing? Anybody know what that is? Okay, that is very unfortunate, but very fortunate that you're here now. So what I did just before flying to Mountain View, that was last week in Germany, I did a screencast of the new real-time shared editing facility that comes with Ganymede. And some of you might know Neil Bartlett, who is another fairly well-known Eclipse committer. He Twittered me this morning and said, hey, you and your org are famous. And then, of course, he asked me about a bug that is in real-time shared editing and supposed to be removed. And you and your org refers to that screencast. So if you haven't seen the screencast, then I will just do another live demo and we'll show you, well, something similar with another hint at World of Warcraft or something. Because in the very first screencast, I implemented an org class instead of a person class, the standard boring example. So Scott Lewis and I are here. Scott is the project lead on the Eclipse communication framework, of which I am a committer on. And I think we should just get started with real-time shared editing, the demo. And after the demo, I will tell you a little bit about the algorithms behind it, why it's so cool, and what future steps we're actually thinking about. So, Scott, are you signed in into your XMPP account?
Yep, I'll log in.
All right, you're logged in. I will log into. This is an XMPP server standing in Ottawa, right? Okay. So, all right, Scott, you're the only one on the server. And what I'm going to do now is I'm going to invite Scott to a shared editing session, and both of us are going to flesh out this same class. So let's invite Scott.
Okay, got the invitation.
You got an invitation. Okay, let's check whether Scott is just saying so or he is here. All right, he's in the same class. We're editing the same document. And you know what? Most certainly our edits are crossing on the wire. Conflicts are arising all the time when we edit at the same time. But still, the document is staying consistent, being consistent. So, Scott, what should we do? I'll just implement two fields, and you can flesh out that equals method. I will do a name field.
Okay, and I'll use the name to complete the equals.
Yeah, for instance. Let's call this name. And I'll do another string, and we'll call that, well, I think Tauren have tribes, but you probably wouldn't care if you don't play World of Warcraft or never heard of it. Okay, and while Scott fleshes out that one, I could do something else that makes sense, like, for instance, implement a toString method for this class. So, let me think. Let's return this dot name and this dot. Did you initialize both of those? Oh, we don't have a constructor yet.
I'll put it in.
Okay, that's cool. And what else? Okay, this is basically how it works like. You can edit the same document at the same time without getting alphabet soup or without getting errors everywhere. And it might look trivial. It's not, and I will introduce you to the black magic that is shared editing. So let me okay, thank you, Scott.
Sure.
Where is my presentation? So that was the really short live demo. I will give you a link to these slides, and the slides contain links to even more material and to the screencast, which runs like for 8 minutes and provides more detail on how to use real-time shared editing within Eclipse. So this talk is about collaborative coding, and if I stay within my time limits, then Scott might even say something about general team tooling, and he might say something about the Eclipse communication framework not just being about tools, but also about APIs, actually mainly about APIs. And well, if I just use up all the time, then you won't hear anything about APIs. All right, so collaborative coding in Eclipse communication framework lingo is real-time shared editing with Cola, and Cola is the synchronization engine that I wrote. I started out as a Google Summer of Code 2006 student, did an internship with Google, and that's how it all came about. So that's the agenda. I'll talk a little bit, or very briefly, about my motivation for doing this. I'll give you a conceptual overview about shared editing sessions just so that we have a common basis. I'll introduce you to the challenges, which is just a better word for problems that arise with shared editing, and then we'll explore the solutions. I'll introduce you to the future, not yours, but of shared editing. And well, I hope that after the talk you leave and are all happy and all fired up to try out shared editing yourself. So I wanted to enable pair programming. I was introduced to pair programming by a couple of friends of mine who did that very strictly, and at first I was going like, okay, interesting, but hey, come on, share a single keyboard, you sit at the same desk all the time. I don't know whether I like that. So people who really slavishly follow Kent Beck's pair programming, they probably won't like this and go like, okay, no, you really have to have that single keyboard. I like having different machines, and actually that enables you to do even more. Another thing is you can do live code review with this, of course. Google has a very, very nice tool, internal tool, which has become public, made even public by the creator, by Guido van Rossum, the creator of Python. It's called Mondrian. And now they have an open source version, which has been released. It's called Rietveld, and there is a review board. These are all, let me call them asynchronous review tools, reviewing tools. With this, you could, of course, do live code reviews. Using shared editing, real-time shared editing, you can help tutor, mentor people, or you might have somebody who knows something better than you, who is a domain expert, or, with all the multi-threading coding going on in many teams, you might have a single or two people on the team who know about Java util.concurrent, and, well, why not invite them and have them check your code, or just code together? It's actually the best way to learn, I think. There's a lot of people who say, hey, examples are the best way. I think if you have somebody who can teach you, it's even better. So obviously, real-time shared editing this way is independent of geographic restrictions, which is especially important for open source teams like us, for instance. I mean, Scott, how often have we met before, like once in person?
Person to person once before.
Right. And we've been working for 2 years, together. So this is a tool that will help you with things in team structures like that. It enables you, or is resilient to location limitations. That means if you're in an open plan office, or if you're just sitting in an office with like 4 or 5 people, pair programming can become a bitch, because you're loud, you're talking all the time, and people will not like this. So the ultimate goal, summarized, making coding more social, effective, and fun. You know what? Might sound utopian, but this might not be the right tool in any case. If you have to be totally concentrated, sitting and trying to solve an algorithmic problem, actually, then you shouldn't have your IDE fired up. You should use pen and paper, I think. But still, with many things like, wiring APIs together or learning stuff, this is actually a good tool, is my personal experience. So what we've showed you just now is 2 participants working on the same document, which currently can be a text file, a Java source code file, anything that uses the Eclipse editor infrastructure. These 2 people can work on, or actually are located and working on different machines, and their respective updates to the document are sent over the network. What the synchronizer takes care of, Cola takes care of, is that you, in the end, have a consistent document state. Now, you might say, okay, I'm I'm trying to be diplomatic here, but okay, let's change this. I'm so bright, I'm so smart, Mustafa, you can have a consistent document state if I just, always send the full document over and just overwrite all the changes the other person has done while my document was traveling. Right, because at the end, you will again have the same document, just you won't be intention preserving, because what you want to have is the changes I did to my local document while changes were on their way to me, I want them to be preserved, vice versa for the other editor. That is what Cola does. So let's have a look at this conflict-free ideal of a shared editing session. I'm just introducing you to the type of diagram I will use throughout the talk. So Anna and Zoe are 2 software engineering hacker ladies, and they start out editing on the initial consistent document state. That was what you saw in the example as public class torrent. So just imagine this green bar being, a line of text in a source file. What happens now is Anna makes an insertion at index position A in the document. The insertion gets incorporated into her local document, sent over the network, reaches Zoe and that Zoe, again, gets updated and integrated into the document. No problems so far. Zoe does an insertion at the beginning of the document, index position 0, incorporates the change gets sent over the network, lands at Anna, and again, the document is updated. Now you will say, hey, Mustafa, I don't think I need this synchronizer. Yes, you do. This is the totally and absolutely, well, the most optimistic example you could probably have. So just reviewing what I showed you, we had the same document state, we had some editing, and in the end, we ended up with the same document state. Consistent documents, intention-preserving changes, because Anna wanted to make a change somewhere in the middle of the green section, and Zoe wanted to make a change somewhere, or not somewhere, at the beginning of the document. Both these changes ended up at their respective positions. So again, recapping real fast, no conflicts because Anna generated, a change on the common document state that also Zoe had, sends it to Zoe. Zoe updates the unmodified local document with the incoming change. Zoe generates a change herself on this same document that they both have now. The change gets sent to Anna. Anna updates her common document state now, and we're all set and all happy because we have strictly sequential execution. This is ideal, but very, very unrealistic, especially when you code at the same time. So one of the challenges that you run into when implementing, realizing something like this is that, reviewing Anna inserts something at index position A, the change gets sent over, the change is traveling on the network. While the change is traveling, Anna does another update to our local document, inserts something at index position 0, gets incorporated, but what if this packet now travels much faster than the packet that was sent before? So that's one of the problems you can run into. What happens is Zoe gets this first change, the second change that Anna made, that's the insertion at the document beginning, then the initially first change arrives also at Zoe, but gets inserted at the wrong position. And that is because this change moved all the index positions that insertion A expected further to the right. Well, of course, this old, this insertion at index position A that was generated on an old document state does not know any of this and still inserts at index position A where actually it should have been moved further. So this is, let me say, fairly easy to solve if you just briefly think about it. In-order message sending and reception has been solved by other people, by network protocols. So you just use TCP. TCP takes care of sending stuff in order and receiving stuff in order. Or you can make life even easier, build on an application level protocols that builds itself, again, relies on TCP. So, and if you're really, really smart, you use the Eclipse communication framework because that provides for an abstraction and you're absolutely free to transparently change the provider, the communication application level provider that you use for your shared editing session. For instance, you could use XMPP to have encryption. You could use Skype for the same type of communication. So another challenge that is not as easily resolved is, first of all, one of the requirements we have with this is we want text editors to be responsive. That's what we've been used to forever, right? I mean, what we have here is concurrent edits to a shared resource, which is the document. Now just imagine, well, doing strict locking on the document would never work. I mean, if you want to type something but still have to wait for the negotiation happening to the remote side and then freeing up your document again, nobody's going to use that. And actually, I doubt that it's usable for interactive text editing sessions. So local changes need to be applied immediately. Another problem, network latency. So messages will cross on the wire when you work like this. And when you immediately apply local changes to your local document state and communicate over the network, which again introduces slowdowns, then you have an incredibly high probability for conflicts, for messages just crossing on the wire. And let's have a closer look at such a cross on the wire conflict. Anna, again, inserts something at index position A, communicates the change. At the same time that Anna generates this insertion at index position A, Zoe inserts something at the beginning of the document she has, incorporates it to her local document, That change gets communicated over the wire, ends up at Anna, and let's review this. Is this intention preserving? Anna wanted to have something, Zoe wanted something at the beginning of the document. Okay, it lands there. That's nice. Anna wanted something in the middle of the green section. That's also nice. Okay, that very much looks intention preserving. It actually is. But what happens here? Again, same type of problem as we saw before. We have an operation that arrives at Zoe's site, which does not know anything about this insertion at 0, which did a change, did an update on the whole document that affected index positions. That affected index positions that insertion A actually is dependent on, since they happened at a lower index position. So what to do? How to resolve problems like this? There is a mechanism which I've dubbed, which actually others before me have dubbed operational transformations, and it's supposed to take care of issues such as this. When you have operations, a locally applied operation, and an incoming remote operation, which originate from the same document state. That means the documents don't diverge by more than one operation. Then you can apply the operational transformation on the incoming operation in order to yield another transformed version of the remote operation that you can apply directly to your local document. That's what this slide summarizes and also says. So, first of all, we have to think about how do we determine that these two different operations don't divert by more than, or actually come from the same document state. That's actually fairly easy. You stamp each locally generated operation prior to sending it out with a counter. Your local document manages two counters. It's locally applied operations and it's remotely or received remote operations. And actually these two simple counters are enough to communicate state, which is good because it's simple. It saves you from introducing bugs yourself when you realize stuff like this. So local operation count, remote operation count, these are enough to communicate state.
Is that true for more than binary?
Yes, it is. It is a very good question. I would actually ask you all to save your questions to the end, but no worries. I didn't say that, and it is enough because when you extend this case, I mean, the first realization or incarnation of COLA just takes care of the two-way case, but you can actually do a virtual two-way extended to an n-way, and it's you have a hub instance, and then all the others think that they're engaged in a two-way communication, and the hub makes sure that changes coming in get replicated to everybody else, so everybody thinks it's still two-way. All right, but that's a topic of its own, and I'm not going to cover this in detail in this talk since this is all two-way. All right, so we compare the counters on incoming remote operations with the conflicting already applied local operation. Then we use the COLA operational transformation. We input the conflicting incoming remote op, the already applied local op. We get the updated remote operation, and that is ready for application at our local document. So, and since this is all very abstract, when I just tell you this, let's have a look at the diagram that visualizes this. Again, Anna's edit, insertion. Same time, Zoe does another insertion. Cross on the wire happens again. And now we have this, I've dubbed this co-opt, which just means COLA operational transform. Actually, it's not even called that in the code anymore, but abbreviation. So again, what is supposed to go into this? What is supposed to be transformed? Well, it's the incoming remote operation, and it's the locally conflicting operation. And what are we supposed to get here? What is this operational transform supposed to yield here? Well, fairly easy. We saw this before. We knew that, when you insert at a lower index position than the conflicting change, then you won't have to update anything. That's okay. Since this insertion did not, in any case, move those indices. All right, so that's exactly what we do. No update necessary. Everything's fine here. So what happens here? We have another operational transform. Here the remote operation is Anna's operation. Zoe's operation is the local operation. And now let's think about this. What should happen? Insertion at index position A is what we wanted. Operation is coming in, but we have moved the indices by a length of purple operation that Zoe generated. So that's probably the next index, right? So we should have insertion A plus L, where L stands for the length of the purple operation. And when we do things like this, then voila, we have a consistent document state and we have intention preservation. So this is a little pseudocode because what I showed you is, a very simple case. First of all, it's an insertion versus an insertion. It's not an insertion versus a deletion. It's not a deletion versus an insertion. It's not two deletions against each other, because all of these cases are more complicated than this is. And once you've figured out what operations you're comparing against, you still have to see where the indices are and decide how to update those indices. And what we did is, we have these, either you have a local op is at a lower index. In that case, you have to move the remote op to a higher index. If the local op is at a higher index, you don't have to do anything to apply the remote operation locally. So what this gives, though, is we have a combinatorial explosion. We have to, when you implement, some kind of real-time editing mechanism of your own, because Cola right now is text editing, as I said, but it will be possible we will abstract an API out of this. It will be possible for you to, use this model of optimistic concurrency control, optimistic because you first apply stuff and then you worry later, to your own modeling and real-time shared editing cases and applications, like, for instance, building graphs or UML diagrams. And I say combinatorial explosion because you have to determine atomic operations, like, for instance, deletions and insertions. Eclipse, the whole editing or document update mechanism, actually has another notion of a replacement. That would be a third operation. Now, when we think about this, all of these atomic operations, they have to be somehow, you have to define proper transformations for these. So if you have two atomic operations, that means you have 4 cases. Right? You have 2 possibilities, basic combinatorics, 2 possibilities for the first operation, 2 for the second. If you have 3, then it's 3 square and it is 9. And, it gets worse after that. So the fewer atomic operations you settle on, the better for you. And model compound operations, such as replacements, as, if you can, other atomic operations, like, for instance, insertions and deletions. And a replacement, in the case of Cola, I've realized as a deletion followed by an insertion, and that just works wonderful. All right, so this is just giving, some asymptotic notation so that it looks all more serious, but it's actually not really hard. So the cases we have to think about is we have a number of atomic operations square. I explained why, and that's still, O n square, no big problem there. Then I showed you the pseudocode with the indice checks, with the index checks. That's always 3 for text editing, so it's a constant. It doesn't change anything actually about the complexity. And now comes the good part, good or bad, depending on your viewpoint. For me, it was bad because I was implementing stuff, realizing this, right, writing the code. And this is not a runtime problem. This is an implementation problem. You will just, your code will be terribly bloated if you come up with 50 atomic operations. If you just come up with 2, you don't have to cover that many cases, and things will work perfectly. And thank God it's not a runtime problem, because just imagine having n square complexity that, every professor will tell you, and your boss too, is very, very bad for you, the company, and the safety of your job, I guess. So, okay, it's linear complexity, by the way, so it doesn't hurt really at runtime. So the fewer atomic operations, the better. Now we have another case. And this case is fairly interesting. This case is the one case that I did limit for my talk and distilled a little just to convey the basic idea and the basic solution. We've realized that, or I've told you that that operational transformations are defined on operations that have been generated on documents that did not divert by more than a single operation. Now, what do you do if you've actually applied 5 operations, a number of operations on your local document, and the remote operation on your way to you does not know anything about these changes that happened while it was traveling? You have to have some kind of mechanism, some kind of resolution for that type of problem. So this is recapping what I just said. We have the generation of multiple local changes while the remote operation is still traveling. So upon arrival of that remote operation, the local dock has not just changed by a single operation, but by a whole slew of operations. So the precondition for operational transformations is not met anymore. Let's have a look at that. What does that look like? We have an insertion that Anna makes. Anna likes index position A, I could tell. So she inserts stuff again. Zoe does the same. And now Anna's change, of course, gets communicated, gets operational, or has that operational transformation we talked about. And this works actually. We've talked about this. This is easy to do divergence by a single operation. You can apply this, transform this, and apply this directly, and everything's fine. Anna does something else before she even receives that insertion at index position Z. She does an insertion at a lower position V, incorporates that change, communicates that change. When that change at some point arrives at Zoe's local document, still, the only operation that insertion V does not know of that Zoe generated is still the single insertion at index position Z. We can again apply an operational transformation and can apply this. And it's all intention preserving. We have insertion A at the right position, insertion at index position V, and insertion Z stays at the same place. But what happened to Zoe's insertion Z on its way to Anna? Well, it traveled really, really long, and it arrives at Anna's local document after Anna has executed 2 local operations. Can we apply an operational transformation? Unfortunately, no, we cannot. So what are we supposed to do? Questions so far, by the way? Did I lose somebody on the way? No. Okay. All right. So let's have a look at the resolution, because the resolution is actually not that hard. It just takes, a little thinking about it. So we again execute an operational transformation, and we do that as we did before with insertion Z and insertion A. This will yield a new transformed operation at an updated index position, and we call this purple star. Insertion at index position X star. And where X is the position Z where purple was supposed to go to, plus obviously the length of A. And now we'll think about, can we apply that purple star operation directly to our local document state? And the answer is, unfortunately, no, we cannot, because there's insertion V, and that again moved index positions. So what to do now? Well, we're being bright. We just use purple star for the next operational transformation and transform this before applying it locally against the other operation it's conflicting with, and that yields purple 2 star. And purple 2 star gets another update index, which is Y, and Y again is the updated index from before X plus the length of the gray operation, insertion at index position V. And now that we have this, we can actually execute the remote operation on our local document state and get consistent documents once more and intention preservation. So now I will, just quickly recap and tell you about additional details that I've omitted for this talk, because I thought, time would be running out much, much faster. Time did not run out as fast as I thought, but again, introducing these details would just blow up the talk. As I said, I will give you pointers to more documentation, and if you're interested in this, I'd suggest you have a look at that. So what you have to do actually in order to be able to do these operational transformations over several locally applied operations that are conflicting is you have to manage a local queue of unacknowledged operations, obviously. You have to have them somewhere. You have to know which operations to have not been received by the other editor, by Zoe in our examples, in order to know what to transform against. So you have to add local operations as you apply them to your local document, to your queue, and so that the queue does not, at some point run, or your machine does not run out of memory. You have to remove these local operations, and you have to remove them when you see via the state of operations communicated from Zoe that the operations in the queue have been implicitly acknowledged. Like for instance, if Zoe sends you another operation and that has like a counter of Zoe's insertion has a remote operation counter, that's the operations she received. Oh God. this would give a sudden end to our presentation. But we saved it. Yeah, I got it. So where was I? Yeah, if the counter says, okay, I have received 5 operations from Anna, and you get that operation and see, hey, my local queue, the most recent local operation I have in my local queue has also a local counter of 5, then you know, hey, 5 and 5 equals, so that remote operation knows about my local operation state, and you can empty the queue. So that was that. Another issue that I ran into, see, I've dealt with these algorithms in 2006. Then I've done a lot of other stuff for like 1.5 years, and just for Ganymede, I came back to this and thought, okay, it would be a nice feature to have. Let's finish this, let's update this, make it Ganymede ready. And I forgot about this essential part of the algorithm, which meant that 30 hours before the code freeze, before the Ganymede code freeze, you had me hacking 30 hours. And Scott knows this because he slept during that time and then woke up, and then we did test sessions and everything. So I totally forgot about that you have to update the operations in your local queue of your local operations as you transform them against remote incoming operations. So me saying this like this does not have to ring a bell and not have to, not be very, very clear. But again, if I would explain this, it would just, double the time probably. But if you ever think about implementing stuff like this, read the scientific papers once more. And if you do if you do your own version of COLA synchronization, then keep this in mind, bear this in mind. There is this tricky detail, don't forget about it. It's the virtual update of queued up local operations, and I call it virtual because you update them in the queue, but you actually don't apply those changes to your local document anymore.
I'm going to stop you. You forgot to say, read the scientific paper and then call the project lead.
Yeah, call him too. You mean the project lead on the papers? You really want to have the calls? All right, so then it helps to introduce a notion of state space graph, which you can do. Then you see where how to traverse all the possible document states and everything. But again, that you need once you start fiddling around with the queue. And we're not doing this. So what should the future bring? And this is actually where you come in. Try out the feature. Please, please, please try it out. I think most of you, I guess, will like this. And there will be things, especially usability issues, since, if you do a 30-hour hacking session, usability is the very first thing that you save up on as a developer. So find these issues and just either drop me an email, comment on my blog, send us an email to the ECF dev mailing list, and either report bugs or submit feature requests. One thing that is obvious that we should do at some point is have more than 2 session participants. Another thing is, right now we're sharing single documents. Would be cool if you could share your whole document. And the thing is, actually, COLA would not even have to be changed for this. It's all the surroundings, all the session management, and all the sharing and sending over of the other files that needs to be changed. Because what you would have is you would have a COLA synchronizer for each of these editors. So that's something that would work now. So that's something that I, on the one hand, predict is not going to take long. On the other hand, I'm still a college student. I have finals coming up. So yeah, you might have to wait until August. Oh, college student in Germany. That's why it will take a while. So, and then, another thing we will have to do, or thinking about doing, and that's, I've referred to this a couple of times during this talk, is, extract an API. Make it possible for others to implement other editors, not just text, but also graphics or graphs. Yeah, that's the bright diagrams, anyone? Then deeper integration with Eclipse. That's something I really, really want. That's something we will have to talk about with the UI and platform people on the other teams. Deeper integration means, it would be great if you could see where the other editor is, see multiple cursors. That's great. Or see highlightings. If I want to point out a certain region in the code, I would very much love to be able to highlight that, and that highlight getting communicated and marked at the remote site. So yeah, Scott can talk a little more about this, but then again, I did manage to fill up time.
Why don't we have questions?
Before we have questions, that's the resources. So what I suggest is, okay, drop by my blog, drop by Scott's blog. You can have a look at the ECF pages. And then there's this wonderful screencast Well, actually, it's very simple. It just shows, an 8-minute editing session that I did with my hacking pal, Tom, in Germany before leaving for Mountain View 3 days ago. And that's the exciting thing. So apparently we've struck a nerve with this project because I just uploaded this on Vimeo and it got more than 6,000 views in 6 days. I mean, it doesn't even feature cats or, cute hedgehogs or anything. It's really just me. I mean, crazy, and shared editing. All right, so much for my talk. Hope you all enjoyed it and hope you're all fired up to try this. Yeah, and questions.
Actually, got two.
Yeah, go ahead.
Questions. What makes up an operation? Do you send something over like a keystroke, or you collect them and then send over 20 of them?
Okay, I'm just repeating this for the mic and for the recording. So what makes up an operation? Is it single keystrokes? Is it something else? Actually, it is every change to the document. So, and it is a very good question, better than you might suppose, because for my Google Summer of Code project, I just implemented this to work on single keystrokes, which is not that cool when you copy and paste stuff, because that totally screws up your whole state model. Well, that works now. You can copy and paste code, you can delete single characters, you can delete whole sections of code, all works. So any change to the document gets wrapped up into a Cola update message and gets stamped with local and remote operations counters and sent over the wire.
Second question is, how does it interact with the team environment or checkout files from the source control?
Mm-hmm.
Since you have the same file on two systems, will it check it out on both sides? Or?
So, okay, all I wanted to say is right now it's not integrated with anything beyond this. The focus for this effort was, get the synchronization right. See, I wrote an internal, when I did my internship at Google, which actually also has been open sourced, Perforce Eclipse plugin. So that's a team repository provider, and I would suppose that you need to, have to integrate these somehow. So, but it's not integrated right now. Team repository providers and this. Scott, you wanted to say something?
Right. I mean, that's an area where we definitely are planning to work. We've already got sort of enhancement requests, basically integrate, version control, right? Whatever provider, Subversion, CVS, whatever, with basically the Team API. And we can do that pretty easily because actually we do have sort of other code that allows people